So, welcome guys to our week 12 lecture of the superstructure component. And in this week lecture, we will go through some of the exam instructions and some explanation of the formatting and the expected questions during the exam. And I want you to have a look on the instructions below here. And we have also some practical sample exam question. This exam, final exam, three versions, and also one of the solutions available here. So you need to try or practice the questions before the test. And as you know, the test has already been allocated to the, I have already updated this one here. So the final exam is an online exam, 2 hours time, and it will be Monday, 23rd of June at 4:30 Adelaide time. As you know, also the exam weight is 50% of the course. So the exam has 50% weight of the course. Okay, so for the instruction as well, I want to make sure you read this one. So the exam is open book online exam. You need to answer all the questions in the exam to give you more chance to get higher marks. And also some of the sub question may have different weight. So if it is like 4 or 3 dot points, so they can have different weight. Ensure that all your calculation in bars for each question and clearly show the unit. So the unit is important part, and also the steps or how you get the values or how you get the final answer is also important. So the mark is not given to on the final answer, but it's also given to part of it on the final answer and part of it on the steps on how to show the calculation. Okay. Also the exam, as you know, has two components, superstructure and substructure. As the marker will mark all of the exam at once, so you can answer both parts in same file and then submit the answer to the portal. So the portal will be open on the exam test so that you can submit your work. The formatting of the file can be Word or PDF. So if you like write on paper by hand, you can scan it and make a PDF file or a Word file and then submit the file to the portal. When uploading your exam file, make sure that you include all the pages in the correct order. So you need to give page number so that you can order the pages so that the marker can follow your calculation. Otherwise, it will be hard to follow the calculation if it is not in order. Also, if you need to assume any ungiven data or any missing data, you can reasonably assume the data to proceed with the calculation. Okay. Also, you need to submit your solution within the 2 hours time from the test, the start of the test, and I think we will allow for maybe sometime 10 minutes or something to upload. But if you exceed the time or the due date, so late penalties will be applied according to that. Okay. Do you have any question about the exam instructions? No question? Okay, so let's have a look on the revision file. So this revision file for structures 2 to give you a hint on the weight of the each part and what is the expected question for superstructure part. So for the structures 2, as you know, the structure 2 has two components, substructure and superstructure. Just a second. Okay, so for the substructure part, for the structures 2 course, we have superstructure and substructure. The superstructure is 2/3 of the course or 67% of the course, and substructure is 33% of the course, and this will also reflect on the test. So the exam will be 2/3 of the exam or 67% on the superstructure and 33% on the substructure part. Okay. The course objective was CO1 and CO4 and CO2 and CO3. So the course objective includes the analysis and the prepare structure design for the key structure element. And the key structure elements are designed in this course are purlins, rafters, and columns. And we know how to design in details the rafter and the columns, especially in week 10 and 11, 9, 10, and 11, using the relevant Australian standard. The Australian standard we are using as well are AS 1170.0, AS 1170.1, and AS 4055 for wind. Okay, and also we have AS 4100 for steel. So these are the four Australian standards we are using or we have used in our course. Now, CO4 demonstrate an understanding of the structure behavior under different loads. CO2, we assess the ground condition of proposal construction site and select appropriate advice for design. So this one is for the substructure part. This first two are for the superstructure part. CO3 as well for the substructure component, summarize key concept of geomechanics, site investigation, landslide and stability management, and footings and road pavement. So these are general or a brief of the course objectives for the two parts, super and substructure parts. Okay, now to pass the course, you must achieve both of the following. So you need at least to satisfy these two conditions. So you need to get 40% of the final test for the final exam. This number one. And also you need to get 50% of the total weight or the overall weight of the course. Okay, so this is how to, or the condition to pass the course, 40% of final test and 50% of the total weight of the course or overall weight of the course. And now the topics covered in the superstructure test will be uh, let's write it here. Just a reminder with the topics. So for the superstructure, we will have another lecture on Thursday for the substructure. So in superstructure, we need to know the loads. So load calculations, dead load and live load and wind load. Okay. And for rafter, we may need to already the loads ready. So we need bending moment and shear force diagrams. And we have the deflections. So these three are to design and also using the charts to select the section or to select the cross section. This for rafter. For column, we need to know how to also find the load, dead load and live load and so on the column. And we need to know, in addition to load, we need the buckling lengths. If you remember, LBX and LBY, buckling about X, buckling about Y. And also we need to know how to use the charts to select column cross section or cross section for column. Here cross section for rafter. Okay, so this is the topics covered in superstructure. In addition, we may have a very short and simple question about the from the guest lecture about concrete and reinforced concrete. You can get this question from the I will share with you in the previous exams. Not very hard question. It's very simple question about some of the dot points covered in the concrete and the reinforced concrete guest lectures. Okay. So I will not get any very new or something new in these two topics. So it will be simple question. Okay, let's talk now about the exam. So the exam duration again is 2 hours, and the exam time is Monday, 23rd of June, 2025 at 4:30 p.m. And the exam is online exam. Okay. Do you have any question about that? So here the exam is online examination. The duration is 120 minute or 2 hours. Okay. So this also again the late submission penalties for the exam between 0 and 5 minutes late, 50% reduction of the graded mark. Between 5 and 10 minutes, 25% reduction of the graded mark. Any exam received more than 10 minutes after the exam deadline will not be marked and will receive a 0 mark. Okay, so please try to complete the test and submit the solution within the time. So here's some instructions for the test. The exam is two-part exam, and it will include the superstructure and substructure part. So if you want to divide the time on the two parts, so you have 40 minutes for substructure because it is 1/3 of the test, 80 minutes for superstructure. So this is not obligatory time division, but it's up to you because substructure weight 33%, superstructures weight 66 or 67%. So this means that you need to spend more time for the superstructure part. It is up to you how you split your time between the substructure and superstructure part. Substructure part will be weighting 34 marks, for example, or 33. Superstructure will weight 66. Okay, so substructure between 33 and 34 from 100, and superstructure is 66 to 67%, 1/3 and 2/3. Instruction, again, part of the instruction ensures that you show all the calculation in all parts for each question and clearly write the units. So for example, if you are calculating dead load, including G roof sheeting plus G purlins plus G insulation and so on, you can't just write the dead load equal to something kPa. If you just write down a final answer like this, so no marks or very little mark will be given because you didn't include the calculation details for all of the section of the loads. Okay, so you need to show the details of the calculation, how you get the values or how you get the answers. Your final answer only carries a fraction or fraction from of the allocated marks. Hence, it is essential to show all the calculation, including the equations. So the calculations and units need to be shown. So also one of the important hints that you need some time to make assumption and give suitable explanation if needed. So for example, if it is not given the ceiling value, so you need to assume a ceiling value. If the insulation not given, for example, so you need to assume the insulation. For example, if the rafter section not given, so you need to assume the rafter section or cross section. So similar to the project, anything is not given to you within the details, so I need to assume. And here is some online exam supports. If you have any problem during the test, you can, like for example, if you can't log in or if you have any uh, difficulties or technical problems, you can talk to IT. You can also call them on mobile here. If you are interstate or not in Adelaide, you can call this number. If you are overseas, you can call this number with this key. Please don't hang up even if you are on hold, as the service ticket will be raised once the call is answered. The service ticket will be your evidence if an issue occurs. So this is just like formal thing. So if you call them and they ask you to wait, so you can wait until they fix your problem. This will be your evidence that you already faced a problem. Anyway, we'll try it. If any problem happens, just let me know as well. So I will try to help. But if it is technical problem, like any of this, so I can't help with it. So this is what I am talking about. If you need any clarification of any question in the exam, your course coordinator, which is myself, will be available through Zoom session for the first 30 minutes of the exam period. Okay, so we can use the Zoom link for the course to help you in any clarification needs. And this is my email. Okay. Other instruction about the test. Again, the exam is open book, so you can use any source you want, like the Australian standard and design capacity tables and even lecture notes. Okay, so the exam is open book. Any reference material, printed or handwritten, are permitted. It will assess your knowledge relating to the topics presented in the lecture and tutorial classes and assignment. Remember that the standard design tables will not be provided by us in the exam, so you need to bring your personal copy. So this is for online, so you can use or access the digital copy of the standard and the tables. Okay, so the exam paper will not include the standard or the tables. And this note already, you know already. So the exam is 50% of the whole course. Okay. And this 50% is shared by superstructure component and substructure component. For the exam preparation, you need to prepare for the test. So if you solve this by hand or by yourself, so you will find it easy and straightforward. So reference material, printed and handwritten or soft copies, standard and table and lecture notes. So you need this to be ready with you, if digital or even printed. Uh, pen, pencils, rubbers, and so on. Calculator for calculation, electronic device, your the electronic device, laptop and iPad to submit the test solution to the portal. You will also need your mobile camera to scan and or scan the solution if you are doing it manually or by hand for handwritten calculations. If you are using digital like iPad or digital laptop, you can also do it. But I mean, if you are doing it manually, so you need a mobile camera to scan. Okay. Also, the exam will have different parameter for each student, similar to the project, to avoid any plagiarism and academic integrity issues. Okay, so please avoid plagiarism and the misuse of the ChatGPT or any other AI tool. Okay, you can if you use any source, you can cite the source you accessed within your answer. Okay, but this will delay your or it will take time. So yeah, so it's better to not depend on the AI tools too much. And also, if you use any similar to the report, so if you make your research and find sources that provide the answer you need, so you need to cite the sources you access within your answer, and using the ABA 7 referencing style is required. So the exam will be two questions. One of them is the measure or the design and calculation question. One of them will be small or dot point question. So doesn't need to be on concrete, but just in general, big question for calculations and all the load and beam and column calculations. The other one will be two or three short question about concrete and reinforced concrete. Okay, so this is topics we are talking about. So we have already talking about the topics here. So here is the topics we are all the calculation we need, and here is uh, maybe short question about reinforced concrete. Okay, any question now before we proceed to an example of the calculation? Any question, guys? No question? Okay, so just before we proceed to the revision part, I want to show you an example of the test paper. So this is the online test for the substructure and superstructure part. Here is the instruction to students. The instruction to students and so on may be a little bit different because the exam before was 180 minutes, so 3 hours. So you can read the exam instruction from the course website. But let's go to the superstructure part. So for the superstructure part, for example, here is an example of the question we have. So for example, we have a plan, side view, and elevation for the shed or for a warehouse. So referring to the structure in figure below, considering the assumption presented in table below, answer the following three questions. So the first question or the major question of the test is the first one here. So it is like a shed similar to the project you have done already. Some of the data are given to all of you for the ceiling, for the surfaces, for the roof cladding or the roof sheeting, for the window glass as well. If anything else is not given, like the Berlin size or the rafter size, you can assume. So the questions are the first question is explain the function of bracing system in structure. So this question is to draw the bracing layout and explain the function of bracing. This, for example, in this test. Then calculate the design load, dead load, life load, and wind load affecting the rafter B R2. So in number B, we need to find the loads on beam R2. So R2 is an intermediate beam, so it will carry load width of 7 meter, for example, and then you can determine the dead load, life load, and wind load. Then choose appropriate cross section for a column. So for rafter, you need only to calculate the loads. For column, choose an appropriate cross section for the column. Assume the maximum design actions are as follows and has fixed connection at the base and fly bracing at mid height. And this is a question about column design. So in this example here, we have MX and N. So this also a question of column design. So this was an old test, but I just want to show you the example or the an example of the test. So this is the main question we have. Most of the marks on this question. And the second question is a very short answer questions. Three question, each one is three. So what is the most widely used cement in Australia? Why is concrete secured? What is the use of the equipment shown below? These three questions are from the guest lectures in week 5, 6, and in week 9. So this is a sample of a test. Do you have any question about the sample? The marks, as you can see, for this part is 66. So the marks for the substructure part will be 34. Okay. Any question about the test example I shared with you? Not all of them. Yeah, the tests Not all of them are answered, but at least one of each part has been answered. Yep, there are three exams are provided on the course website now. But I will try to also, because this exams was from not the recent one, so I will share with you also some of the important question to practice before the test. Okay? Because this test, for example, was no, because I am not the course I was not the course coordinator for this test, so I don't have the answer. And this test as well are 180 minutes, so it is different style exam. Okay? So if we go to the course website, here is the exam solution for 2021 test. Okay? So later I will provide more solutions for some other question, but not in this test because uh, the focus of the course has a little bit changed. So we need also to focus on what we have explained during the lectures and during the tutorials. Any other question, guys? Another question from Alex or Daniela or Yog? Okay. So to summarize, what is the main points in the test, or what is the main points we want on the test before the revision? So for question one of the superstructure, which is most of the mark and the calculation, we will have question about maybe load passes or bracing layout or bracing, how the bracing is arranged. And another question for loads on beams or beam, B1 for example, like dead load, life load, and wind load, or or bending moment diagram and shear force diagram for a simple beam. Remember, for a simple beam with a uniform load, so we have bending moments and shear force. Okay, and for columns, so this question one, this question or part two, this number three, column design. The column design includes calculation of LBX and LBY and using the charts to select a column. So these are important topic to focus on for the superstructure part of the test. Okay, sorry guys. Can you see it now? Okay, so for the superstructure part, let's say the question number one, 60% of the test will be about this topic. So the first one is about load passes or bracing, and this part of the course. The second one will be about the rafter, so how to calculate the loads on the rafter or the beam, including dead load, live load, and wind load. Also, we may ask for the bending moment and shear force diagrams for the rafter. This is the bending moment diagram, and this is the shear force diagram. So, bending moment diagram and shear force diagram. Number three is the column design, which can include calculation of buckling lengths, LBX and LBY, and also using the charts to find or select a suitable column. So these are important topics about the superstructure part or about the 60% of the test. Okay. Any question about that? I will try to share as well with you the last year tests or last year exam so that you have 4 copies of the exams. Any other question, guys, before we proceed? Okay, so now let's start. Yes. So now let's start doing some explanation for this example here. So determine the maximum design load combinations for the rafter B1. Assume the internal spacing between the purlin is 1.4 and the wind class is in 2. So here in this example, the wind calculation are like shortened, so you don't need to go through all the calculation because the exam time is limited, so we can't ask for everything. So it will be some of the information will be given for you to reduce the time needed to solve it. So for example, if we have this plan with this elevation view, this side view, and this is the shed. So as you can see, this is our rafter. This is our column. This is our column. So the rafter span is the total span here given as 14 meter. So it is required to find the maximum or the design load combination for the rafter. So how can we find the maximum load combination on the rafter? What do you understand from this part or from the requirement? Do you know what is required? That is the first step. To find the load combination, firstly you need the load. So you need to find the dead load, live load, and wind load on the rafter. So this is the first step. Second step, after you find the load, so you can find the load combination 1.2 or 1.35 G first. 1.2 G plus 1.5 Q, 1.2 G plus 1.5 psi L Q, 1.2 G plus WU plus psi C Q, and lastly 0.9 G plus 1 or plus WU. So we have 5 load combination. So the final answer will be to select which one is the maximum. Okay, so this what is meant by this question here. So it is not required to draw the bending moment, for example, or shear. It just needs the maximum load combination. So in the test as well, you need to read the requirement carefully and don't like waste your time by doing something not required. Okay. Okay, so let's start with the load calculation part. The load we have in this example are dead load, live load, and wind load. For the dead load, what are the components of the dead load? For a roof beam. This is a roof beam, not a floor beam. How I know it is a roof beam? Because this is the roof. So it is a roof beam. That's why the load components are roof sheeting, ceiling, insulation, self weight of the purlins, surface load, and rafter self weight. So G for rafter or G total will be the summation of all of this. So G roof sheeting plus G ceiling plus G insulation plus G purlin plus G surfaces plus G rafter. Okay. For the life load, Q from the tables in AS 1170.1. For the wind, it is given already in as n the wind class is N2. So using N2, you can go to the table to find VH ultimate and VH surface. And then you can find the bridges. Okay. So let's start with the roof sheeting load. So for the roof sheeting, we need to find G roof sheeting. G roof sheeting will be equal to G load from tables multiplied by the load width of the rafter. So one of the important thing you need to show in the solution is the tributary area for the element you are designing. How the tributary area looks like for B1. If this our shed, so beam B1 is carrying half. This is the rafter, right? So this rafter is between this column here and this column here. So this rafter is carrying half spacing from the top, half spacing from the bottom. So it's carrying from top 2.5, from bottom 2.5. So how much is the load width? 5 meter. So 5 meter is the load width. So this is our tributary area for B1. So we need to show this diagram in the calculation just manually like this. So this is the column, column, column. This 5 meter, 5 meter. So if this our B1, so B1 will be carrying this part or this area. So the load width is 5 meter for B1. So we will replace the load width by 5 meter. How we do know what is B1? B1 will be given to you. This is the rafter. So design for the rafter B1. So it should be written to you here. Okay. So any of them is B1. So if you look to the test again, For example, he asked here to design R2 or B2, whatever the name, so it will be given to you. Okay? Any other question, guys? So now, yes, no problem. Anything will be clearly, so you will know clearly what to design. Don't worry about it. Okay, so this for the roof sheeting. So what you need to know, the roof sheeting. So you need to assume a roof sheeting if it is not given, or if it is given, you need to use it. Okay? So for example here, if we assume a roof sheeting, just a second to find the table. Have you used the roof sheeting table before? Have you used the roof sheeting before? Roof sheeting table before? Okay. So for example, just try to find the sheeting, the file. So for example, if we go to this table here and select one roof sheeting. So whatever the roof sheeting you want to select from here, for example, if we used, for example, custom ORB Ascent 35, for example. So if it is not given to you, so it's up to you. If it is given, so you need to use what is given. So this is an example of not given data. So I assume roof sheeting, custom ORB, Ascent 35. The mass of this one is 5.5 kilogram per meter square. So this is the important information you need to know. So now if we substitute here, so G roof sheeting equal to 5.5, this in kilogram per meter square. So you need to multiply by 9.81 divide by 1000 to be in kilonewton meter. Then multiply by the load width, which is 5 meter. So this gives you the value. So this value is the value of the dead load due to roof sheeting. So for example, 5.5 times 9.81, it is 0.27 kilonewton per meter squared. So this means that G roof sheeting equal to 0.27 kilonewton per meter kilonewton per meter, not per meter square. So because this kilonewton per meter squared time meter, so it become kilonewton per meter. So now this means that the beam or the rafter B1 has a dead load from the roof sheeting G roof equal to 0.27 kilonewton per meter. So this is our first part. Second component, we need to assume insulation. Because nothing is given, so I will assume everything or every parameter. It is not given doesn't mean it is not existing, guys. So we need to assume if it is not given. So for example, if we go to our lecture here, so this is material for insulation. So we can assume insulating sheets, the mass, or sorry, the weight, the density of this is 6.9 kilonewton per cubic meter. So this is the insulation sheets. So what we can do is now G insulation equal to the load from or the density from the table, which is 6.9 kilonewton per cubic meter. Actually, this is specific weight. So the specific weight from the table multiplied by, we need to assume a thickness, multiplied by the load width. So any calculation for the rafter will depend on the load width. So what I have done here is G insulation. I assumed the insulation sheets here. G insulation will be equal to the value I got from the table or the specific weight, 6.9, multiplied by the thickness of the sheet, multiplied by the load width. So G insulation equal to 6.9 kilonewton per cubic meter times, let's assume it is 10 millimeter. So 10 divided by 1,000 to make it meter, multiplied by the load width. How much is the load width for the rafter? 5 meter. So G insulation equal to 6.9 times 0.01 divided by 5. So it is 0.345 kilonewton per meter. So all the loads on the rafter will be in kilonewton per meter. So this is G insulation equal to 0.345 kilonewton per meter. Assumed. How I get a thickness assumed. Why we need the thickness here? Because the standard give us this value as a specific weight. 10 millimeter or 20 millimeter. A reasonable assumption is 10 millimeter or 20 millimeter. For the thickness, this is a reasonable assumption. Okay? So this for the insulation. What is the next load width? Sorry, what is the next load? The ceiling, for example. The ceiling also is not given, so we need to assume ceiling. So assume ceiling as, if we go to the other slide, from here. So I assumed a ceiling of BCB of 13 millimeter. How much is the load from the ceiling or the self weight of the ceiling? 0.29 kilonewton per square meter. So if we go to our example, so we assume a ceiling. This ceiling is BCB or Portland cement plaster. The weight of this one is 0.29. So how to convert this to load on the rafter? G ceiling on the rafter or the beam will be equal to the load from the self weight of the ceiling multiplied by what? Load width. So equal G ceiling will be equal to 0.29. It is already in kilonewton per squared meter times 5 meter. So meter with squared. So it becomes 1.45 kilonewton per meter. So this is the ceiling weight. Go to the rafter. The next part is the surfaces. So the surfaces, we can assume it as 0.1 kilonewton per squared meter. So G surfaces on the rafter equal to 0.1 kilonewton per squared meter times the load width. How much is the load width? 5 meter. So G surfaces equal to 0.1 kilonewton per squared meter times 5 equal to 0.5 kilonewton per squared meter. So now we have got the roof sheeting, ceiling, insulation, and surfaces. So we still need to find the self weight of Berlin and the rafter self weight. So if you read the question, one of the given data to us is the internal spacing between Berlin is 1.4 meter. So we already know the Berlin spacing equal to 1.4 meter. So what this means? This means that if this our uh, span 14 meter, or if we work on half, because we usually work on half. So if we work on half of the span, so this 7 meter has 1, 2, 3, 4, 5, 6 bullet. So each distance is 1.4, 1.4, 1.4, 1.4, 1.4, 1.4. So 1.4 times 5 equal to 7 meter. So just this information will save you the time to find or determine the spacing. So it is already given to us. So how many Berlins we have in 7 meter? Because we need the number of Berlins. So we have 6 Berlins. So now G Berlin will be equal to self weight of Berlin or load from one Berlin multiplied by number of Berlins divided by 7 meter here multiplied by load width. So G Berlin equal to, how we get this one? We need to assume a section of the Berlin. So if the section of the Berlin is not given, we need to assume Berlin. So what is the Berlin we will be assuming? Or if it is given? So let's assume it is given as, or we assume it as from the example here. Z 200 or C 224. The mass is 7.24. So if we go back, so we assume a section of 224. The mass of this Berlin is equal to 7.24 kilogram per meter. So G Berlin will be equal to 7.24 times 9.18 over 1,000 to make it kilonewton, multiplied by number of Berlin is 6 Berlins, divided by 7 meter, multiplied by the load width is 5 meter. So this give us a value of 7.24 times 9.81 divided by 1,000, multiplied by 6, multiplied by 5, divided by 7. So this is 0.302 kilonewton per meter. Okay, how we get the number of Berlins? Because it is given to us. Here we have the Berlin spacing, or assume the Berlin spacing as 1.4. So if the Berlin spacing 1.4, this means that we have, because we have, this is 7 meters. So in each 7 meter we have 1, 2, 1, 2, 3, 4. So this is 1.4, 1.4, 1.4, 1.4, 1.4. Another option, maybe I can give you the number of Berlins direct. Okay. Yes. So divide the spacing by the width. So 5 over 1.4. Sorry, 7 over 1.4 give us 5 spacing. So one option to find if you can to do it like that. So the number of Berlin, if it is given. So if the Berlin is spacing given to us direct. 1.4 meter. How can we get the number of Berlin in this 7 meter? So number of Berlins will be the width 7 meter over 1.4 meter plus 1. So it will be 5 plus 1 equal to 6 Berlins. Why plus 1? Because if you divide 7 over 1.4, this give you the spacings. So how many spacings we have? 1, 2, 3, 4, 5. But if you have 5 spacings, so you have 6 Berlins. So 1, 2, 3, 4, 5, 6 Berlins. So to get the correct value, 7 meter over the width over the spacing plus 1. Okay. Any other question? So this for what? For the Berlin. What is the last load we need to find? the rafter self weight. For the rafter self weight, what we need to do, we need to assume a section if needed. So if the section is not given, so you go to the section here. So we need to assume a section for the rafter. For example, if we assumed 360 UB 56.7. So if we go back to our slides, so assume a rafter section 360 UB 56.7. So now G rafter will be equal to the value. This is the mass. So the mass 56.7 kilogram per meter need to multiply by 9.81 divided by 1000 to make it kilonewton. So this will be equal to 0.556 kilonewton per meter. Okay, so this for the rafter weight. So now if we go back to our load calculation, we have got the roof sheeting load. This number one. The value is 0.27. For insulation, the value is 0.345. For ceiling, 1.45. For surfaces, 0.5. For Berlin, 0.302. And finally, for rafter, 0.556. So the total dead load after all this calculation, G total equal to G roof plus G insulation plus G ceiling plus G surfaces plus G Berlin plus G rafter. Okay, and the test it doesn't need to be all of that because this might take a long time and we need to ask for other question as well. But it's up depend on the given. So for example, if I give you a floor beam instead of a roof beam, so the values will be different. If I give you already some values ready to save the time, but if nothing given to you, so you need to find this six component of the load. So G total equal to the values for the first one is 0.27 kilonewton per meter. G insulation is 0.345 kilonewton per meter, plus for the ceiling 1.45 kilonewton per meter, plus for the surfaces 0.5 kilonewton per meter. For the Berlins, it is 0.302 kilonewton per meter. And finally, the rafter is 0.556 kilonewton per meter. So G total equal to the summation of all of that. So the summation of all of that will be 0.27 plus 0.345 plus 1.45 plus 0.5 plus 0.302 plus 0.556 equal to 3.42 kilonewton per meter. So the dead load on beam B1 is 3.2 kilonewton per meter. Any question about the dead load? So as you know, or as you uh, faced in the projects part 1 and 2, the dead load calculation is the time consuming one because we have a lot of components and a lot of calculations, but the dead load, the live load and wind load are much simpler than this one. Any question before we proceed to live load? Okay, that's good. So the next step or the next load we need to calculate is what? Live load or imposed load QB or QB1. This is a roof. So the load, live load on the roof from AS 1170.1 using the formula 1.8 divided by A plus 0.12 and should be more than or equal to 0.25 kBA. So this is the formula from AS 1170.0. What is A? A is the tributary area of the rafter. What is the tributary area for the rafter? Here is the tributary area of the rafter. So what is the dimension of the tributary area of the rafter? It is 14 meter by 5 meter. So A here equal to 5 by 14 meter. So now Q or live load on roof equal to 1.8 divided by 5 times 14 plus 0.12. Usually this value is less than 0.25, but if you don't have time, you can uh, mention it is less than 0.25 and use 0.25. But the value is 1.45 kPa or kilonewton per square meter. Less than 0.25 kPa, which is not acceptable. So we will use live load on the roof equal to 0.25 kPa. This is not the live load on B1. So Q B1 will be equal to 0.25 kBA or kilonewton per square meter times the load width. The load width for this rafter is 5 meter. So Q B1 equal to 0.25 kilonewton per square meter times 5 meter equal to 1.25 kilonewton per meter. So the load on the rafter, the live load on the rafter is 1.25 kilonewton per squared meter. Okay. Any question about the dead load and live load? What is the next load we need to find now? The third load we need to find is wind load. In wind load, the information given to us that the wind class already given to us as N2 or N3. Let's have a look here. So N2 is the wind class. It's already given. So what is the first step? First step is we need to find the wind speeds. So the wind speeds using the table and for N2. Where is this table? If we go to this example here, not given in this one. So we need to go to AS 4055 for the wind speeds. So I will just open the lecture for wind to see how the table looks like. Okay, so this is the wind. So we need to use this table A 2.1a. So for N2, the wind speed is 26 for serviceability and 40 for ultimate. So if we go back here, so using table 2.1a, VH equal to 26 and VH is 40 meter per second. This for serviceability and this for ultimate. In this example, we don't need both of them because we are not designing the beam for deflection. So you can just find the ultimate wind pressure. So the first step is the ultimate, sorry, or the design wind speeds. The second will be the pressure or the wind pressure. For the wind pressure, if you remember, Q U times CB equal to the pressure P, and QU equal to zero point 0.5 rho air VH squared divided by 1000. So QU for ultimate equal to zero point 0.5 rho air is 1.2 times 40 squared divided by 1000. So this value is 0.96 kBA. So this is the value for ultimate wind Q. Then CB for roof equal to -1 and positive 0.63. Where these two values come from? If we return back to the slides, the other slides, the beam, the column, and the example of wind. So these are the wind coefficient CB. As you know, we are working on the net pressure for general area. So we are designing a rafter. So the factors are these two here. So for a rafter, these are the two values. Okay. So the factor are -1 and positive 0.63. So this is two values we know now for the CB. So now the pressures on the roof, two values, -1 times QU, which is 0.96 kPa, and the second one is positive 0.63 times 0.96 kPa. So this value of QU, these two values are for CB. This will equal to the first one, -0.96 kPa. Negative means suction or upward. The other one will be positive, which is 0.604 kPa. The positive sign means pressure or downward. Okay, so this is two values. So you need to have two values for the rafter in ultimate limit state case. So those are the pressure. Now the loads, wind loads. How many wind loads we have? Two as well. So we have WU downward and WU upward. Both of them will be the pressure times the load width. So it will be one of them positive 0.604 times 5 meters. So this is the load width. Any load width for the rafter is 5 meter in this example. And this is QU downward. This will give us a value of 3.202 kilonewton per meter. And this is downward load. The other one is negative 0.96, which is QU upward, multiplied by 5 meter, which is also the load width. This will give us a value of negative 0.48 kilonewton per meter. The negative sign means upward. So this one up, this one down. So now the last step is to find the ultimate load combinations for this one. For the ultimate load combinations, we have 1.35 G, 1.2 G plus 1.5 Q, 1.2 G plus 1.5 Epsi L Q, 1.2 G plus WU downward plus Epsi C Q, 1 and the last one or number 5 is 0.9 G plus WU upward. So from the previous calculation, we have found that G equal to 3.42 kilonewton per meter, Q equal to 1.25 kilonewton per meter, and we have two values for W. WU equal to 3.02 kilonewton per meter down, and WU equal to 4.8 kilonewton per meter up. So these are the values we got now. So if we substitute, we'll do the substitution in the next page. So number 1.2 times G. G is 3.42. Sorry, 1.35 G. Which equal to 4.617 kilonewton per meter. Second one, 1.2 G, 3.42 plus 1.5 Q, 1.25. So this is Q, this is G. So this value equal to 5.98 kilonewton per meter. The third one is 1.2 G plus 1.5 times epsi L times Q. How much is epsi L for a roof? If we go back to the example here, so this is the table for epsi L. So epsi L is the long-term factor. For roof, other roof, it is 0. So if psi L is 0 in this case, so this means that this term is 0. So it becomes equal to 4.104 kilonewton per meter. Number 4 will be 1.2 times 3.42 plus WU. WU downward is this value 3.02. So plus 302 WU downward plus psi C Q. Q is 1.25. Psi C, if we go back, psi C is 0 as well. So psi C and psi L is 0 for roof. So this is 0. So this term is 0. So we have this value equal to 7.124 kilonewton per meter. The last one is 0.9 G, 3.42 plus WU upward. Upward means it is negative, so if we go back, so it is negative 0.48. So this one will be replaced by a negative sign, 4.8. This one equal to 0.9 times 3.42 minus 4.8. So this is a negative 1.722 kilonewton per meter. Negative sign means this load is acting upward. So which is the critical load combination for this example? We have two critical combination. One of them is this one, the largest of the first four, because all of them are downward. So this is our critical load combination, downward. And we have this one here is the critical load combination upward. So the final answer or the summary for the final answer is the critical load combinations are two. The first one we have for this rafter, 14-meter rafter, we have a value of the load downward equal to 7.124 kilonewton per meter. So this case is downward. Number 2, we have the other case, which is for the upward case. Upward, so the load is acting up, not down. So we have 1.722 kilonewton per meter. So this is upward case. Okay. So this is the critical load combination for us. The first one is the downward case. The second one is the upward case. Okay. Do you have any question, guys, about this part or this question? Yes, this is the end for this problem. To find the critical loop combination for the column and the for the rafter or for B1. Yep, something similar to this. Okay. Any question, guys? One last thing is you remember the guy from the reinforcement steel institute, Eric? He sent me that they will give or they will provide a prize for the top performing student in the course. He will send me the details. He sent the details by mail, so I will post an announcement on the forum about that. But I just want to let you know that one student who will get the high marks in this course will receive a prize from Syria, SRIA, and I will share with you the details once I receive it. Also, he will send me the details, the reinforcement handbook details, and I will distribute to you. Hopefully I receive it today, but I didn't receive it yet, so I will try to distribute to you once I received it from him. One last thing before we go, do you need class next week in week 13 so that we can practice more on the test or not? Okay, so I will try to arrange that, but instead of doing 3 classes, so it will be optional class. So who want to come, will come. Maybe we can make it online or face to face. What do you prefer, guys? Okay, so maybe we can do that. So in next week, week 13 class, I will run 2 sessions, 1 hour and 1 hour, for example, to practice the two parts of the course. So 1 session for superstructure, 1 session for substructure. Okay. For example, from 2 to 3 for superstructure and 3 to 4 for substructure. Is it okay? Okay. Actually, the class should end this week, but just to help you more to practice for the test, we will try to make this two face-to-face classes. Okay. We'll share the details with you soon, but just to let you know that there will be classes. Thank you. I will see you tomorrow in the presentation if you are coming, and we can discuss more.
Sorry, just one question.
Okay, but can you do it quickly because I have a meeting at 3, please?
Yeah, all good. Can we get like more specifically, I just need all the download versions of all the Australian standard stuff. Because
Yeah,
some of
I remember you mentioned that, so I will try to do this before tomorrow. Okay?
Yep. All right, cool. Thank you.
So I need to print them and scan them again and upload them because otherwise it will not work.
Yep, all good. Right, thank you so much. See you tomorrow.
Thanks, Luke. See you tomorrow. Bye.
Bye.